checklist on the topic of advanced area, arc length, and volume problems, part one. So let's look at a review of the area between two curves formula. Remember, if you use a vertical rectangle with dx, then it's f of x minus g of x, where f of x is above g of x, so it's the top minus the bottom. Versus if you have a horizontal rectangle with dy when you're doing area, then area is f of y minus g of y, and f of y is the one to the right of g of y. That's the one where the bigger x coordinate goes first. So this is a with calculator problem. So it says determine the area enclosed by the curves. And notice I didn't scale the x and y axis here. We're just going to draw a rough sketch so we can see the area enclosed. So let's start with the TI-84 here. So we'd go, we'd enter these two functions in here. So x cubed minus 9x squared plus 16x plus 7 for y1. And then you go second e, and then put the whole exponent in parentheses here. You don't have to put the 0, but just 0.23x and then close parentheses. And then for a window size, you can try different window sizes, but this one's a little weird because you have to make it big enough because there's actually going to be two regions enclosed instead of just one. So one window size you could change it to fit all that. You just got to play around with it. It's negative 10 to 10 on the x minimax and negative 20 to 20 on the y minimax. And then if we graph that, whoops, re-highlight these so they'll re-graph them. If it graphs them in the order you type them in. So there's the graph of the x cubed graph there, and there's our exponential graph. So notice there's actually a region enclosed right here and another region enclosed right here. You make the x minimum a little smaller, you can see that even better here. Let's see if we can make that like negative 2. Okay, so there's our first curve, and there's the second one. All right, so on paper here, let's just sketch what that looks like here. And what I'm going to do is, because we're going to need two integrals rather than just one, since there's two regions enclosed, so that we don't have to write down quite as much, and you can use this strategy anytime you want to use a more compact notation in your integrals. I'm just going to call this function f of x, and just define it to be x cubed minus 9x squared plus 16x plus 7. And that's the curve that looks something like that. Just a rough sketch of it again. And then I'm going to define g of x to be e to the 0.23x. And g of x looks something like that. That way we don't have to write these whole things down over and over again as we are setting up our integrals. All right. And then on the Inspire here, new document, add graphs. I'll just have x cubed and then minus 9x squared plus 16x plus 7. Then hit the down arrow, and then our g of x is e. Now here you don't have to put the parentheses because it keeps it up in the exponent there, 0.23x. And let's just again change the window size here. Let's make menu window settings. Let's again go negative 2 to 10 on the x minimax, and let's try negative 20 to 20 on the y minimax. Just so we can see the regions enclosed a little bit. There we go. So notice we've actually got 3 points of intersection. We need to find all 3. So let's do that first on both calculators and then write them down. So I'll go back to the 84 here. So I'm going to define this one. I'll call this one A, and B, and this one C. And notice, even before we do that, notice to decide if you want to use horizontal or vertical rectangles. Well, Notice if we use a vertical rectangle, it always stays between the same two curves. So that's a good choice on this one. With the x, notice if you used a horizontal rectangle, that wouldn't work very well. You'd have to split it up, and then you'd have to take this function by itself and solve it for x, and this one you can't really isolate the x, so that's not really a feasible way to do it. And then on the other one, same thing. Vertical rectangle would work better here. Horizontal, you'd have to split it right here, and it wouldn't stay between the same two curves. There's dx, since it's a vertical rectangle, and dx. All right, so let's go ahead and find a, b, and c, and then we can write them down, what they are, and store them in our calculator. So let's go back to the 84 here. Second calc intersect, number 5. First curve, enter. Second curve, enter. Guess, I'm going to just type in a guess. Looks like mine's around 0, so I'll just type in 0 and enter. And it's negative 0.320 if you round it. May be accurate to at least the thousandths place. Okay, and then let's store it in our calculator. Second quit, store alpha A. And then let's find B, second calc intersect. First curve, enter, second curve, enter, and guess. I'm going to guess this one's around 3, so I'll type in 3. And it's 2.913. Notice we're just getting the x coordinates because we're using dx here, so everything has to be in terms of x. And let's store that one, second quit. Store alpha b. And then finally the last one, second calc intersect. First curve, enter, second curve, enter. I'm going to guess this one's at 6. And it's 6.462. Again, write it on paper and store it in your calculator. Store alpha c. All right, and then on the Inspire, same thing. Find the points of interest, menu, analyze graph, intersection, lower bound, click to the left of it, upper bound to the right of it, and then highlight it. Bar, store, A. You want to move it around as you can here, and let's find the other two, menu, analyze graph, intersection. To the left of it, lower bound, upper bound to the right of it, there it is, highlight it. Variable store as B. Enter. And one more, and you can move these to get in the way there. Menu, analyze graph, intersection. Lower bound to the left of this one, upper bound to the right of it. And there it is right there. So let's highlight the x coordinate. Variable store as C. And let's write down our integral on paper now. So notice for the first region here, it starts at an x coordinate A, that's our lower limit, and stops at an x coordinate B, our upper limit. And on this one, the top minus the bottom, well, the one on the top has a bigger y coordinate, that's why it goes first, is f of x minus the one on the bottom is the blue one, g of x, which is the height of the rectangle. And that's all we integrate when we're finding the area. So the whole thing times dx. And then plus, the next integral would be from b to c. However, notice on this one, the one on the top is actually switched. Now it's g of x that goes first, and minus f of x. Notice this is where I'm taking advantage of the fact that I defined them. You can use whatever you want, function notation-wise, to name each of these. If I didn't do that, then I'd have to write these whole equations here for f of x and these whole equations here for g of x, which would also work, just take a lot longer to write down. And finally, we just have to put this in our calculator, see what we get for the area. So here we can go math, number 9, function integrate. So on this one, this is f1, f of x minus g of x is y1 minus y2, so vars, right arrow, y variables, y1 minus vars, y variables, number 1 function, y2, comma, x, comma, lower limit, alpha a, comma, upper limit, alpha b. So that closed parenthesis will give us the area of that first region enclosed. And then plus math for 9, function integrate. This time it's g minus f, so it's y2 minus vars y variables y1, comma r variables. Oops, too many commas there. The variables x, comma the lower limit alpha b, comma the upper limit alpha c. And then be accurate to the thousandths place. So we get 66.124. Now you don't have to put the units because they're not specific, but it is area, so it would be units squared. And let me just confirm that on the Inspire here. Again, this is going to look like the newer, those of you guys that have a newer 84 would also look like this. So doc, insert calculator, and the integral's right here from A to B. Here, f of x was f1, so var f1 of x minus var f2 of x dx. Divide integral and then plus another integral. This one's from B to C. This time it's g minus f, so that's var f2 minus f1. Minus var f1 of x dx. And we get the same answer. And that concludes the notes for part 1 of the Notes for AP Calculus on the topics of advanced area, arc length, and volume.